Hey guys, and welcome to a new video in this point cloud tutorial. In this video here, we're going to talk about camera trajectory. So in this video here, I'm going to show you how we can actually get a number of different kind of images and how we can combine that into a trajectory. So we'll have a camera trajectory, and how can we combine those two images together with our camera trajectory to one point cloud that we can then do operations on and so on, as in all the other videos that we have throughout this tutorial. But first of all, remember to join Discord server. I'll link to the description here. You can join channel, chat about computer vision, deep learning, AI, and so on. You can also become a member of the channel if you want to support the channel with a small monthly fee. Everything will go to create more and better quality content here on the channel. Also, if you're a member of the channel, I can also help you out in your own projects. If you have some problems, I can help you out, give you some guidance and so on if you're a member of the channel. So thank you guys. So let's jump straight into code here. I'm going to show you line by line how we can play around with these different kind of things. First of all, we're going to see how we can set up the intrinsic parameters, get some intrinsic parameters for some cameras from Open3D. And also if you have your own camera, how we can specify your camera's intrinsic parameters. So you can then use those later on to actually create your point clouds, do some kind of operations and so on. So first of all here, we're going to test the camera here in Open3D. So we're basically just having a prime sense default camera here. So this is just a built-in camera here with the intrinsic parameters into Open3D. So we can just go into open3d.camera.pinhole camera intrinsic parameters. We want to get the intrinsic parameters of this prime sense default camera. So we'll get the focal length, optical center, and so on. So basically here we can just pass this into this function or like this method here, the pinhole camera intrinsic. So this will just return our intrinsic parameters here. So this is how we can set up an object for our intrinsic camera parameters that we can then use later on in the function, as I've shown you throughout the other videos. In this tutorial here, like when we're doing post estimation and so on, we need to pass in our intrinsic parameters to some of the algorithms. We can also set it up in another way. So if you have your own camera and you know your parameters, you know your intrinsic parameters, and you just want to set it up into Open3D and create an object, then we can just have this pinhole camera intrinsic parameters, and then we can just pass in all the values here that we have. So we can pass in the image dimensions, the focal length, and also the optical center here of a camera. So we can actually create this object here in Open3D with our own camera's intrinsic parameters, which is often the case that we want to do because we want to calibrate our cameras, get our intrinsic parameters, and then we can then store those in this object here, or like in this class here in Open3D. So here we're just going to print out the intrinsic parameters for our prime sense default. We're also going to print out the intrinsic matrix or like the intrinsic parameters for this camera that we set up here, like our custom camera. But we can actually also write it to our camera intrinsic parameters. So when you have already set up your camera intrinsic parameters, you can just save it into a JSON file, and then you can just read it in later on again. So you don't need to specify your parameters, or like if your parameters are changing, and so on. So here we're just going to write our pinhole camera intrinsic parameters to our test.json file, and then we're basically just going to read it here again. So we're just going to call write pinhole camera intrinsic and also read pinhole camera intrinsic from the IO module inside of Open3D. And then we're just going to print it here. So our X and our intrinsic matrix here will be the same as our Y value here. Down here, we're going to read a directory after all, because the idea behind this video here is actually when we have a camera, if we're moving around in the environment, we will have the trajectory of our camera. And then if we want to combine the images that we take when we're moving around in the environment, we both know the trajectory and we have the images. Then we can actually have both our color images and our depth images. We can combine all of it to one point cloud. So this is what we're going to do down here. First of all, we're going to create an empty list with all the point clouds that we're going to get. So we're going to have which you're going to have in a number of different kind of images. We're going to load in 5 images, and then we're going to combine those. We're going to create an RGBD image from our color and our depth map. And then we can actually use the intrinsic parameters to convert those RGBD images to our point cloud. And then we can use our camera's trajectory to create a single point cloud from those images that were seen from different kind of positions, because we know the camera's trajectory here as well. So here we're going to have our trajectory equal to o3d.io. Then we're going to read in our pinhole camera trajectory. So this is just some test data here that is provided by Open3D that we're going to use. Again, if you clone it, everything will be on my GitHub as well. If you clone it from Open3D, you will have the test data as well. So we both have the RGBD images and also the trajectory. So here we're just going to read in a trajectory for a camera moving around in an environment, taking images from different positions. And then we can just then write the pinhole camera trajectory here to test.json. So we both have our pinhole, camera intrinsic parameters, and also our trajectory. Then we're just going to print our trajectory's intrinsic parameters, so we can go inside our trajectory object, get the zeroth parameter here, and then we can print intrinsic parameters, because the intrinsic parameter here is actually like how the two images here are related to each other, how the trajectory moves from one frame to the other frame. So that will be our intrinsic parameters, and we can also get the direct intrinsic parameters from our trajectory down here, which will be our zeroth element here as well, or like the frame. So when we have a directory, if we have like, for example, 5 poses in our directory, then we can just specify, or like we can just index it here. So this will just be the first point in our trajectory. We're going to get the intrinsic parameters and print that here. So down here, we actually have our for loop. We're running through a range in 5. So we have 5 frames here that we're going to run through. Then we're just going to read an image from the test data set here again, where we both have a depth image, or like a depth map that we're going to read in. And then we also have a color image. So we'll have our RGBD image that we can create down here under. So we're just going to store it in our im1 variable here and im2 variable, and then we can create one here, which is the im variable, variable, which will be an RGBD object from Open3D. So we're going to basically just call this function, or like this method here, create from color and depth. We pass in our color map, our depth map, and some parameters here as well that we need to specify. These are just some default parameters from Open3D. So then we have our RGBD image object here. Then we can get the intrinsic parameters and extrinsic parameters for that specific pose, or like for that specific image. So we're just going to take the ith element of the parameters. Then we just take the intrinsic parameters and extrinsic parameters. So then we have that. Then we can actually create a point cloud from our RGBD image together with our intrinsic and our extrinsic parameters. So we're going to set our point cloud here equal to open3d.geometry.pointCloud.create from RGBD image. We pass in our RGBD image, our intrinsic parameters, and our extrinsic parameters for that trajectory that we loaded in from our camera. Then we can just append that point cloud to our PCDs down here at the bottom. So when we have been through our for loop 5 times, we have our object, or like a scene from 5 different kind of angles with different kind of depths, but we know the camera's trajectory, so we can combine that into our single point cloud. So we're just going to append those point clouds here to our point clouds, and then down here at the bottom, we're actually like going to draw our geometries, or like draw our point clouds that were appended up here in the for loop. So if you're just going to run this block of code, or like this program here, we can actually see what is going on and what the output will be. So this will actually be the point cloud here. So all the point clouds here that we're plotting from different kind of angles, but we're combining it with the trajectory as well, because we're taking into account the intrinsic parameters and also the intrinsic parameters of our camera, so that we can see that this will be a this will actually be a combined point cloud, because we're taking into account the camera's trajectory. If we just go into the folder here, first of all, we can just reveal it here in the file explorer and go into the test data and see how that looks. So if we just go in here, we can just go back here to the examples, test data, and then we can go into RGBD images. We have our color images, and these will be the 5 color images that we're going to see. We can see some small changes here. I'll just try to make this a bit bigger. So here we can see that there is some changes between the 2 images. Now it won't change, but there's actually like some changes here from image to image, if we can see it here. But when we're combining it, taking in the camera trajectory into account, we can actually combine it to one single point cloud. Again, you can do this with an arbitrary number of images. If you're just walking around in the environment with an RGBD camera, or like a stereo camera or something like that, then we can actually get the camera's trajectory together with these images here, and then we can combine them into a single point cloud, which could be like if we want to map some different kind of environments and so on. But here we can see the printouts here that we get. So we're testing the camera in Open3D. Then we get the prime sense default, the default parameters here, or like intrinsic parameters. So we have the focal length here in the X direction and the Y direction. We have the optical center here as well. Then we can also see the image width here and the height of our cameras, or like from our camera. Then we can access our intrinsic with our intrinsic matrix, as we're going to do down in the for loop. We can also read the directory here and combine all the RGBD images. But here we can also see the other results that we get out. So this is the object, or like the object, camera object that we created ourselves. So we just specify the focal length and also the optical center here by ourselves for our own camera, and also the width and the height of our, or like the resolution of our camera. Then down here, we're reading its trajectory, and then we're combining all the RGBD images together with our camera trajectory. So here we can see we just get out this transformation here. So this will be our trajectory intrinsic parameters. So we have the rotation here, and then we also have the translation here for the first camera, or like the first image that we took with our camera in our camera trajectory, because here we're just printing out the 0th element of our trajectory parameters. So that will be the first image. Again, we're doing the exact same thing down here. We're just taking the ith element, running through all the images that we have in our folder, and then we're just visualizing the point cloud here. Again, we have combined all the RGBD images to one point cloud. Again, we could do this by moving around in the environment, creating really nice point clouds by just combining our RGBD images. So again, it can be used for a lot of different kind of things. So thank you guys for watching this video here, and remember the subscribe button and bell notification under the video, and also like this video here if you like the content and you want more in the future. It just really helps me and the YouTube channel out in a massive way. I'm currently doing a computer vision tutorial where we're talking about basic image operations, camera calibration, stereo vision, how we can use stereo vision to get depth information, combine that with point clouds, do point clouds operations, and so on. So if you're interested in that computer vision tutorial, I'll link to it up here, or else I'm gonna see you next video, guys. Bye for now.